some maths then. Okay, so today we are going to be looking at the concept of volume with the open box problem. Now, for this, you will need sellotape and scissors, pencils, rulers, and some card. Now, you could perhaps try it with some paper, but card will be better for what we are going to be doing today. So, first of all, with the card, now, I don't know if you want to come in there.
Yep, come in for a close-up.
So, we need a 20 centimetre by 20 centimetre piece of card that looks like this. So I'm just going to show you how you go from the A4 to that desired square shape. So I'm going to measure in, so I want 20 centimetres from one side there. So I'm going to put a marker there. Okay, then I'm going to draw a line at that 20 centimetres, okay, and from there, so I'll just double check that is 20 centimetres, yes it is, so I'm measuring 20 centimetres along that line, and put the marker there, and then draw my other line that's going to be parallel to the edge of the paper, well, card, okay, then I'm going to cut that square out, and hopefully should end up with something like this. So we've got what's going to form the net of our cuboid. Okay. Now, strictly speaking, it's not going to be a cuboid that we create because the top face is not going to exist. Hence the name open box container. So yes, this is 20 centimeters by 20 centimeters. I'm going to cut out a square from each corner to give the net. Now I'm going to start with 4 centimeters, but that's something that we can change later on, depending on how big or small we want this to be, but 4 centimetres to start with. So marker at 4. Okay, now actually if I've got 20 centimetres here, if I take away 4 from there, I'm going to end up with what, miss?
I think that might be 16.
16. So if I put a marker at 16, draw these two vertical lines in, again making sure that these lines are parallel with the edge of the square. Okay, and if I measure 4 from there, and then 16 at the other side.
Looking good.
And again, vertical lines. Okay, now what were vertical have become horizontal because I'm rotating it. So, we've got the format that we need. I need to cut out these squares. So I'm going to cut one out with the scissors along the line. Being careful not to cut further than where the two lines meet, because that's going to form a fold line. Okay, so I've cut out a square at each corner, each vertex. Okay, I'm going to do that 3 more times to hopefully end up with something that looks like this. So how's this one looking, miss?
Looks perfect.
That look okay? That, yeah, okay. Now, with the ruler, these lines that we've got that form this net, okay, we need to fold along those lines. So I'm going to take the 30 centimetre ruler, hold it quite tight and on the line, and then fold over, nice clean fold on each line. So it's 4 times in total. Oops, getting caught with the tape here.
Looking good.
Yeah, is that,
very neat.
So one more. Okay, so now we've got the net with these fold lines. Okay, so we've got the open box container, but of course we need to secure these faces at these edges with a little bit of tape on each corner.
Might be a good idea to get your tape ready to go beforehand.
Yeah, always good idea, miss. Thank you for sorting this for me, miss, sorting the props and things.
You're
okay.
welcome.
Let's have a look. Okay, so we'll do that at each corner, so that then hopefully we should end up with something like this. So this is our first open box container. Now, you may remember before I mentioned taking 4 centimetre squares out from each corner, okay? That actually has given us this dimension here, this height of 4 centimetres. So the square along the bottom, if I've taken 4 centimetres there, done it at each side, remember it was 20 centimetres to start with, the original square, 4 from there, 4 from there. That's going to leave me with what length there then, miss?
20, take away 4, take away another 4. Would that be 12?
12 centimetres, I'd agree with that. So the base of this open box container is hopefully a square shape that's 12 centimetres by 12 centimetres. Now we can look at the space within this object. otherwise known as the volume. Okay, so we've got 12 centimetres by 12 centimetres and 4 centimetres high. And actually, by multiplying those dimensions together, it gives us the volume of the space inside this open box container. Measured in what, miss? So if I'm doing 12 centimetres multiplied by 12 centimetres multiplied by 4 centimetres, what would the units be?
Would that be centimetres cubed?
Centimetres cubed, absolutely. And actually, we've got some examples here of different lengths and widths that you can use, altering the heights each time. Now, you'll notice we've actually started here with a height of 0, which just leaves us with a square of length 20 centimetres by 20 centimetres, increasing it each time. I did it as an example with 4, but your task, ladies and gents, is to see if you can maximise the space within this open box container. In other words, maximising the volume. And actually, if we have a look at what you could then do with that, so let's have a look forward on here. We've got some pictures here. I don't know if you can quite see those there, miss.
Just about.
Of what some students did last year with these open box containers, filling it nice and neatly with sand. You could use flour, sugar. Obviously, ask your parents for permission before you start raiding the kitchen cupboards. Okay, make sure you clean up after yourselves. Okay, but essentially, what we did was we weighed these containers on some scales, and obviously, because the weight is determined by how much space is inside the container, i.e. the volume, we want the volume to be as the maximum, okay, as big as possible. So, good luck with that, people.
Goodbye, sir.
Thank you.